Greetings, Math 111. I'm going to do a quick question for you. This is section 9.3 and question number 4. I sent out a little bit of information via email, but had some more questions. Again, remember, your numbers could look a little bit different because WebAssign does use an algorithm to change some things. But let me read you the problem. Is the national crime rate really going down? Some sociologists say yes. They say the reason for the decline in crime rates in the 1980s and 1990s is demographics. It seems that the population is aging and older people commit fewer crimes. According to the FBI and the Justice Department, 70% of all arrests are males aged 15 to 34 years. Suppose you're a sociologist in Rock Springs, Wyoming, and a random sample of police files showed that 34 arrests last month, 24 were males aged 15 to 34. So that's my R is the 24, my N is the 34. Use a 10% level of significance to test the claim that the population proportion of such arrest in Rock Springs is different from 70%. So different than, so my alpha is 0.1, so that's part of the answer to part A. My p-value is 0.7, that was given in the problem. H naught, p equals 0.7. H1, my alternative hypothesis, is that p is just not equal to 0.7. And again, these are little p's, these are historical information. So first of all, we're saying we're gonna test, is it really 70%? Or do we think that really the number has changed? One way or the other. Don't know which way, but has changed. So question part B says, what distribution I'm going to use? I'm going to use my standard normal because n times p is greater than 5. What was n? N was 34. What is p? 0.7. And n times q is greater than 5. My p hat, which is not part of the question, but I just want to point something out. So p hat is 24 divided by 34. And if we were to do that part on our calculator, we get 0.0705888, and there's more decimals that, we don't want to round in the middle of the problem. So when you do your actual computation, don't round and then put it into your z formula. So my z formula says z equals p hat minus p over the square root of p times q divided by n. So here's my values. So p hat, we are literally going to do 24 over 34. Don't round, just do that on your calculator. Minus p, that's that little p. Oops, I meant to write the number in. Minus 0.7, and then divided by p, which is 0.7, q is 0.3. Remember that q is equal to 1 minus p, so that's equal to 0.3. And then I'm going to divide by 34. So that answer, see, I already did it on my calculator. That answer is 0.074848, okay? And I believe it tells you to round to 2 decimal places. So 0.07, in this case, for these values, your values for n and r could change. So they're probably different. Also, your alpha might also be different. Okay, so here's the part that gets a little trickier. Here's the piece. It says find the p-value of the test statistic. So if I draw my favorite normal curve here, and you probably already did, because everybody does that, went ahead and selected the correct graph at the bottom, and what you would find is that a graph that kind of looks like this. It doesn't have much white space in the middle. It's mostly, let's see, they kind of use blue. And we know it's two-tailed because it's, the alternative hypothesis is p is not equal to 0.7. So we know it's two-tailed. These values down here are my z. So I'm going to use 0.07. This happens to be negative 0.07, right? It's symmetrical. So it's everything bigger than z equal to 0.07 and everything less than z equal to negative 0.07. Well, I'm going to choose to look up the negative 0.07. So 0.4721. That's the area on this side under the curve. I know that it's symmetrical, so I know the other side is going to look the same. 0.4721. So that's the area under the curve, both sides. So in order to get my total p-value, my big P is going to be equal to 2 times the 0.4721, which is 0.9442. Okay, so for this set of answers, that would be the correct answer. Now, what's interesting is that Webb's hand sign got a slightly different number. They got 0.9403, so super close. Why? Because they're using algorithms that crunch the whole numbers. We're using charts that only go to 4 decimal places, so that's the difference. But again, it won't mark it wrong. That would be okay. So the last part of this question has to do with accepting or rejecting. So it says, based on your answers to part A and C, so let me get rid of this part in the middle. So based on your answers to part A and C, we want to compare. So here's my p-value. Here's my alpha. So alpha is 0.01. What is my p-value? 0.9442. Sure enough, that's greater than. So when the p-value is greater, then we fail to reject. So we fail to reject because the data is not significant. Okay, it's not significant. So in other words, this could have just been a goofy sample. This could have been a goofy sample that said 24 out of 34. It's not a big sample size. It wasn't enough of a change from 0.7. Remember, let's see, our number was 0.07. Our p-hat was 0.07588. This value is really close to this original p-value. So yeah, it's not a significant change. It doesn't tell us. So how do we conclude this? It says there's insufficient evidence at the 0.10 level to conclude that the true portion of arrest of males aged 15 to 34 in Rock Springs is different than 0.7. So when I see this big of an area under the curve, it's very rare we're going to reject H naught. Because what this means, again, this is what is the chance that this was a goofy sample? Well, pretty good chance. All right, have a good day, guys.